Welcome back. This is an Aleks homework video on understanding the effect of induction on acidity. So induction comes from physics. If you were to take a balloon that was charged negative, if you scrape a balloon on your hair and you pull electrons off your hair and you have a balloon, latex balloon full of electrons, you can actually, if the room is dry enough, you can take that balloon and stick it to the wall. What's happening is the electrons on the balloon have an effect on the electrons in the wall. So the electrons in the wall that are free to move will run away from the electrons that are coming on the balloon, and the only thing left on the wall is the positives. The negatives are hiding behind those positives, and then you can stick the balloon to the wall with just charge, the positives in the wall attaching to the negatives on the balloon. That's induction. So induction is when something that's charged has an effect on something else that's charged. Okay, essentially turning something that would normally be neutral into a charged, at least partially charged idea. All right, so they're going to give you two acids and ask you which one is going to be more acidic. So you have to think, okay, if it's more acidic, what that means is it's going to give up its hydrogen more readily. So if it's giving up its hydrogen easier, then that's going to be a stronger acid. And if it's giving up its hydrogen easier, then the electron that hydrogen is sharing must be diverted somewhere else, going away from that bond. So if you can pull that electron that the hydrogen is linked to the acid with away, then it's easier for that hydrogen to be donated. The stronger the acid, the more easily that hydrogen falls off. So we're going to look at the other elements that are in this molecule, and the ones that steal electrons are the ones that are going to make it a hydrogen that can be donated easier. So we're looking at the things around it and which one steals electrons more. Well, stealing electrons is the idea of electronegativity. So electronegativity, every element has a certain pull on an electron. So for instance, in the first example where I have HClO3, the Cl has a high electronegativity. And so it's going to pull the electron away from that hydrogen and make it really easy to be acidic. Now the iodine also has a pretty good electronegativity, but we're asking the question, which one has a stronger one? So whichever one is going to pull on that electron more will make it easier to donate. So I simply look, the first one I've got Cl and I, okay? So I've got a Cl attached to that OH group, and it is going to pull that electron away from that H and make it easy to donate. So I look at Cl and I look at I, and everything else is the same. So Cl is a stronger electronegativity. That means it is going to pull the electron away and the hydrogen is easier. So I'm going to say that means that will be an easier to fall off, so it'll be a stronger acid. Okay, does that make sense what we're doing? Okay, let's do another one. So the second one, you've got SeO4 and SeO3. All right, so the selenium is electronegative, but both of those are the same. The oxygen is electronegative, and those are the same except that you have more on the first one. So you have, in the first example, you have H2SeO4, so you have one selenium and 4 oxygens. So looking here at the bottom, you have 5 electronegative atoms that are pulling the charge away from that hydrogen and making it easier to donate. And you're going to actually, it's diprotic, so you're going to donate one, and then you're going to come back and donate the second one later. In the second example, where H2SeO3, you have 4 electronegatives. All right, so all things being equal, 5 is going to pull that electron stronger than 4. And since it does, it makes it easier to donate. And so if it's easier to donate, then it's going to be more acidic. So we saw that this one was already, and then this one too is going to be higher acidity. In your third example, you have H2SO3 and H2CO3. Well, this is an easier one. You're just going to look at the sulfur and the carbon and find out which one is a higher electronegativity. So I have to look. So we have the sulfur is 2.58 and 2.55. Oh, so close. But sulfur is slightly more electronegative, and since it's slightly more electronegative, that means it's going to tug on that one more than the others. Okay? So that means that in this particular example, now it's never like this, it's always random. Aleks is always random, but in this example, the first of each was the stronger being pulled away. That means the electron's easier to fall off, or the hydrogen's easier to fall off, and likewise, for that reason, it's a stronger acid. So I hope that helps.